Hello, let me present our plan for manufacturing pressure sensor. Our team consists of Junhyuk Lee, Ryuji, and my name is Junwon. Our report is mainly divided into 5 parts: introduction, mask design, pressure sensor fabrication process, measurement system setup, and our overall schedule. In the 17th century, Torricelli and others invented the barometer to measure atmospheric pressure. Later, Mandela and others proposed pressure gauge. By the 19th century, strain gauges that convert mechanical deformation into change in resistance became widely used to express mechanical signals as electrical signals. Until recently, the development of piezoelectric sensors has made it possible to measure pressure more accurately. When the pressure sensor is subjected to pressure, the sensor made of metal or other materials deforms, and through the Wheatstone bridge circuit, the change in the sensor resistance is converted into an electrical signal change to express the change in pressure. In this project, we plan to use chrome as the material of the pressure sensor and attach it to a fixed diaphragm. When the diaphragm is deformed by pressure, the sensor also deforms. The Wheatstone bridge circuit, composed of chrome sensor on the film, can successfully convert the mechanical signal into an electrical signal output. Therefore, after determining the size of the sensor, we will first use L-Edit software to design 3 different masks, namely open window mask, meta window mask, and backside etching mask, as shown in the example in Figure 1. Figure 2 shows the entire fabrication process we planned. Firstly, perform thermal oxidation on the 4-inch silicon wafer after piranha cleaning. Then, AG5214E is spin coated on the front and back side of the silicon wafer with the oxide layer. And then, photorisography patterning is performed using an open window mask on the front side. The silicon wafer is then etched with DHF to remove the unwanted SiO2 part. After removing the residual photoresist, TMAH etching is performed to remove the unwanted silicon part. Next, a second thermal oxidation is performed, and the 200 microchrome is deposited on the front side. And then H5214E is spin coated on the chrome layer and patterned using a metal pattern mask. Next, the exposed chrome part is etched. After removing the residual photoresist is spin coated on the front and back side, and photorisography patterning is performed on the back side using a backside etching mask. The sample is then placed in BHF to etch the exposed SiO2 part. After etching, the residual photoresist is removed, and finally, TMAH etching is performed to remove the excess silicon part. Finally, remove the completed pressure sensor, and the fabrication is completed. Figure 3 shows the equipment we plan to use. such as a sputter system for chrome deposition, the spin coater for spin coating photoresist, and so on. Arduino is a popular open source hardware platform consisting of a board that can easily connect sensors to different parts and software that can command the board. The reasons why Arduino is so popular are as follows. First, it is affordable. Second, it is open source. Third, it provides a simple and intuitive programming environment. Fourth, it has the convenience of easily connecting and removing various parts. Our goal is to amplify the output voltage signal generated by the piston bridge circuit and different pressure into the RPM HX711, then input it into the Arduino module ESP32 and transmit it to the computer via a specific radio transmission module to record the data in real time. So now let's look at why we use ESP32 and HX711. ESP32 is a 240 MHz dual-core processor and microcontroller with built-in Wi-Fi and Bluetooth capabilities. So there is no need to add a specific wireless transmission module separately. It is widely used in IoT projects as it supports up to 3-4 GPIO pins and can be easily programmed through Arduino IDE. In particular, it is very useful to be able to send sensor data in real time using wireless capabilities. However, while piston bridge is useful for measuring resistance, it is difficult to ESP32 to read directly due to its very small voltage signal generated. The HX711 is a low-power, high-precision analog to digital converter and amplifies low-voltage signals such as pressure sensors well. This makes up for the fact that in the previous EXP32, the piston bridge is useful for measuring resistance, but the voltage signal it generates is too small to read directly by ESP32. In addition, the HX711 allows the signal to amplify to selectable gain values, and then convert it to digital values with high precision through a 24-bit ADC. In addition, HX711 offers reliable measurements by reducing noise with built-in filtering. These advantages make HX711 widely used for precision pressure measurement, an overall flowchart of the measurement system. First, circuit connection. Connect the VCC pin on the HX711 to the 5-volt pin on the ESP32 and the GND pin to the GND pin. Connect the DT pin to the GPIO22, the SCK pin to the GPIO23, and the output of the pressure sensor to the sensor plus and sensor minus on the HX711. Second, code writing. Arduino IDE writes code including HX711, Wi-Fi, and web server library. Initialize HX711 and enter Wi-Fi connection information. Third, upload the program. Upload the code to ESP32 set the pressure measurement cycle. Lastly, check result. Check the IP address of ESP32 in serial monitor and enter it into a web browser to determine the measured voltage. This is the entire schedule we planned. Thank you for your attention.